Hey guys, welcome to the engineering world. Subscribe the channel and support our work. Here is the free mock test series for SSC JE, VIZAG Steel NLC exams. Here is the explain the solution of free mock test of production part 2. You can attempt this test at any time. Link is given in the description box. So go there and attempt this test. The first question is, in DC welding, the straight polarity, that is electrode, is negative, resulting. Actually, in DCSP, that is direct current straight polarity, the work is positive and electrode is negative. Just a minute, I will show you. Here, the work is positive and electrode, this is electrode is negative, and hence as work is positive, heat generated at work is high, so depth of penetration is high. As heat generated at electrode is low, so deposition rate will be low. The next question is, in HSS tool materials, the element tungsten can be completely replaced without changing the material property by. It is a straightforward question, and the answer for is molybdenum. Then the next question is, in a 2D CAD package, the clockwise circular arc of radius 5 specified from P1, which is 1510, to the P2, which is 1015, will have its center at. Here, this is the arc and it travels like this. I will show here. Travel like this, that is from P1 to P2. So from figure we get the answer to travel like this, so from figure we get answer as 15 as to 15, that is center. For this type of example, please draw the figure so that you can get answer in just 3 to 4 seconds. Then the next question is, the total angular moment in degrees of a lead screw with pitch of 5 mm to drive the worktable by a distance of 200 mm in a NC machine is. Here, pitch of lead screw is 5 mm. Okay, if in question thread specification is not mentioned, then it's a single thread, and for single thread we know pitch is equal to lead, so we know that lead is the distance travel in a one revolution. Okay, so in one revolution is equal to 5 mm distance covered, so in 1 mm 1/5 revolution is completed. Then just by applying basic mathematics we get 14400 degrees. The answer is A, 14400 degrees. The next question is, using a Taylor's tool life equation with exponent n is equal to 0.5, if cutting speed is reduced by 50%, then the ratio of new tool life of the original tool life is. The Taylor tool life equation is V into T raised to n is equal to constant. Here n is equal to 0.5 is given. Let V1 is equal to 100, so V2 is equal to 50 as reduced by 50%. Then from the given condition and by using Taylor's principle, we get T2 divided by T1 bracket raised to 0.5 is equal to 2. Then just applying basic mathematics, that is putting values in equation, we get ratio of T2 upon T1 is equal to 4. Then the next question is, the DC power source of arc welding has the characteristics 3V plus I is equal to 240. This is characteristics where V is the voltage and I is the current in ampere. For a maximum arc power at electrode, the voltage should be set at. Just use the use of mathematics, that is maximum and minimum concept, given 3V plus I is equal to 240. So I is equal to 240 minus 3I. As we know that power is equal to V into I. V into, here I we found 240 minus 3I. So V into 240 minus 3V. Sorry, I did mistake there. It's I is equal to 240 minus 3V. Okay, writing mistake, sorry. Then power is equal to 240V minus 3V square. For optimum power, we have to differentiate P with respect to V. So dP by dV is equal to 0 is equal to 240 minus 6V. So we get V is equal to 40 volt. Then the next question is, most of the metal cutting heat goes into. Actually, out of heat generated in a machining operation. Maximum heat is transferred into the chip, that is 75 to 80%, then 15 to 20% to the work, and remaining, that is 5 to 8% to the tool. Okay, so the correct answer for this is moving chip. The most of metal cutting heat goes into the moving chip. Okay, then the next question is, when 3-2-1 principle is used to support and locate a three-dimensional workpiece during machining, the number of degrees of freedom that are restricted is. Here 3-2-1 principle diagram is shown. Actually, this is a 3-2-1 principle. I am showing top view, side view and front view. These are the 3 pins, these are the 2 pins. Actually it is in side view, and this is the 1 pin. Okay, then due to the 3 pins, these 3 pins, there is 1 linear and 4 this, like this motion, 1 linear motion is restricted and 3 rotary motions are restricted. Due to that 1 pin, it restricts the 1 linear. Due to this linear distance, this linear movement is restricted. So, and due to these 2 pins, okay, due to these 2 pins, 1 linear and 2 rotational movements are restricted. So total, due to all this, that is with pin 3, 2 and 1, here 3 pin restrict 1 linear, 4 rotary degree of freedom, 2 pins restrict 1 linear, 2 rotary degree of 1 linear, 2 rotary degree of freedom, and 1 pin 1 linear. So total 9. The answer is 9 degree of freedom are restricted. Then the next question, in an oxy-acetylene gas welding process, oxygen and acetylene are mixed in a ratio of 1.5:1. The flame is, here ratio of oxygen as to acetylene is 1.5, so oxygen is maximum amount, so it's oxidizing. Then the next question is, during orthogonal cutting of a mild steel with a 10-degree rake angle tool, the chip thickness ratio was obtained as 0.4, shear angle in degrees. It is just a formula based question. The formula is tan theta is equal to r cos alpha divided by 1 minus r sin alpha. Our chip thickness ratio or cutting ratio given 0.4, alpha rake angle given 10 degree, then we have to find shear angle, that is theta. So by putting all values, we get theta is equal to 22.94 degree. Then the next question is, match the following. Here process and media is used. Then EDM, dielectric medium is used. ECM, electrochemical machining, electrolyte is used. For USM, ultrasonic machining, abrasive slurry is used. And for EBM, it is vacuum. It is done in vacuum. So that these are the answers. Then the next question is, the rake angle of a cutting tool is 15 degree, shear angle 45, cutting velocity 35 meter per minute. What is the velocity of chip along the tool face? Here I am showing the velocity triangle. This is the chip velocity, chip flowing velocity. Then this one is the chip cutting velocity. Here is some problem occurring. Oh, this is the shear angle. This is rake angle. So by using the sine rule, that is ratio of side and the sine of opposite angle to that side are equal, we get V divided by sine of, in bracket 90 minus 5 plus alpha is equal to Vc divided by sine phi. So we get Vc is equal to 28.58 meter per minute. Then the next question, when a cylinder is located in a V-block, the number of degree of freedom which are here. I am showing this one is a cylinder. Here this one is a fixed one because it can't go down. Okay, these also are restricted, these two are also restricted. Okay, then just see in a upper plane. Okay, this rotary movement also restricted. If you consider this as a plane, if you consider as a plane, and if you viewing from top, these two are restricted, and these also two are restricted. I have shown this fixed. Then total are 7. Okay, these two, and 3 linear. Then the next question is brazing and soldering are. The brazing and soldering are heterogeneous joining methods. In brazing and soldering, parent material will not melt it, hence these are heterogeneous. Then built up edge is formed while machining. The straightforward question answer is ductile metal with cutting slow speed. Okay, the zigzag cavity in a block of high strength alloy is a finished machined. This can be carried out by using laser beam machining. Then the next question is, among the conventional machining process, maximum specific energy is consumed in. Here the answer is grinding. Maximum specific energy is consumed in the grinding. In grinding, 1/3 of abrasive are act as a single point cutting tools, and remaining are simply rubbing onto the workpiece without doing any machining. Hence loss of energy due to friction is high, so specific cutting energy is high. The next question is in ECM the MRR is due to. Actually, electrochemical machining, MRR is due to the ion displacement. Okay, I will explain in the lecture series. Here the next question, a milling cutter having 8 teeth is rotating at 100 rpm. The workpiece speed is set at 40 mm per minute. The feed per tooth is. Here we have to find feed per tooth, that is FT. Its formula is Fm divided by NZ, where Fm is workpiece feed, N is RPM, revolutions in RPM, Z number of teeth. So just putting the values in formula, we get answer 0.05 mm. Then the next question, the metal powder used in thermit welding of the steel is. In thermit welding, the metal powder is made of aluminum. So sorry, here the correct answer is aluminum. Okay, aluminum, thermit welding aluminum powder. Okay, the next question, in a machining operation, if the generatrix and directrix both are straight line, the surface obtained is. Actually, generatrix is a line generated by cutting motion, while directrix is a line from the feed motion. Cutting motion generatrix, feed motion directrix. Here I am showing geometries. The first, just erase me. Okay, erase this. Okay, the first one, generatrix is a line and directrix is also a line, so it's a plane. So the answer is for this question is plane. Okay, then the next question is, only negative rake angle is used with falling tool material, as carbides are weak in tension, hence negative rake angles are made of carbide tool carbides. So answer is carbide tool steels. So here we conclude our lecture. Please give support us and subscribe our YouTube channel. Thanks, all the best.